Hello, welcome to the second day of 10.1. Today we'll be learning a little bit about margin of error. Now margin of error is going to be a z star times standard deviation of the population over the square root of n. Now margin of error gets smaller when z star is smaller, when sigma is smaller, or when n gets larger. However, if we want to change something, the only thing we can really change is the n, because sigma is going to be what it's going to be. Um, that's standard deviation for the population. That's not something you can really change. And your z star, you don't want to accommodate your z star just to get a certain margin of error. So your n is going to be the thing that you can control. Now, if we want to find a particular sample size, so if we're looking for n here, our formula is m is greater than or equal to z star times sigma over the square root of n. For example, researchers would like to estimate the mean cholesterol level in a particular variety of monkeys that is often used in laboratory experiments. They would like to estimate it to be within 1 milligram per deciliter of blood of the true value of mean at a 95% confidence level. A previous study involving this variety of monkeys suggests the standard deviation of cholesterol level is about sigma is equal to 5 milligrams per deciliter. Find the number of monkeys. So we use our formula times sigma over the square root of n. We want our margin of error to be within 1 milligram. So that's 1 milligram. At a 95% confidence interval, our z star is 1.96. It suggests that the sigma is going to be 5 divided by the square root of n. Now there's many ways to solve this. What I'd do is I'd multiply 1.96 times 5, and you get something just a little bit less than 10. I'll take my calculator out. 5 times 1.96 is 9.8. So we have 9.8 over the square root of n. And now what I would do is I'd multiply both sides by the square root of n, multiply by the square root of n, and I get the square root of n is greater than or equal to 9.8. Now I have to square both sides to get n is greater than or equal to 96.04. Now you can't get 0.04 of a monkey. So the amount of monkeys that are needed are 97. So 97 monkeys will do it. Now some cautions with confidence intervals. The data must be from an SRS. If you use a different method, if you use a different design, you'll need a different method. So we have different methods that are needed for different designs. The other methods you would learn if you continue to take stats past this course. There are no correct methods for inference from data that are haphazardly collected with bias of unknown size. So the confidence interval cannot account for bias in collection. Outliers can distort the results. The shape of the population distribution matters. If the population distribution is normal, then each sample from that will also be normal. You will know the standard deviation. You must know the standard deviation for the population, and the margin of error and confidence interval covers only random sampling errors. All right, here's your homework. Good luck.